presenter. So we have with us Leonhard Peböck, who's the product marketing manager at Fronius, and he's talking about a somewhat different topic, sustainability at Fronius life cycle assessment. I personally think that's an important topic. I also work as the executive advisor to Solar Power Europe, which is the solar lobby association of the European industry, and sustainability is very high on our agenda because on the one hand, solar is pretty climate friendly by nature. Nevertheless, you always can do more, and so it's great to learn from Leonhard from Fronius about their developments. The floor is yours, Leonhard.
So hello from my end here. I hope you can hear me well. Perfect. Then I will just share my slides. Maybe you can give me a short info if you can see them.
Yeah, just go on presentation mode.
Yeah, now it should be full screen, right? Perfect. Mm-hmm. Okay, then I will start. Thank you, Michael, for the introduction. As you said, my name is Leonhard Peböck. I'm working for Fronius in the residential sector, and I have also some, let's call it special topics, like, for example, sustainability. Recently, we conducted a life cycle assessment for our hybrid inverter. Yeah, and I'm very proud to achieve some very good results here and to present it in this conference to you today. A short look at the agenda. I want to do the Sol Hub principle today. The Sol Hub is our hydrogen pressure refueling station with up to 700 bar. So we go with a lot of pressure through the presentation because we have a lot of content, a lot of information, and quite limited in time. So we will do it very fast today. I will start with a short product presentation, just one slide about the inverter with which we conducted this life cycle assessment. Then I will explain what is a life cycle assessment, why do we need life cycle assessments in future. Then the content of the life cycle assessment, so how we manage the data collection. I will present one scenario at a glance because there are many scenarios when it comes to life cycle assessments, and of course the results and some further information. Yeah, let's have a look at the product with which we conducted this LCA. That's our latest hybrid inverter, the Gen24 Plus. It's an inverter in a single and a three-phase version, so two different versions, the Primo Gen24 Plus, Primo for single phase, and Simo for three-phase, so symmetric feed-in. The Primo ranges from 3 to 6 kW, and the Simo, the three-phase device, ranges from 3 to 10 kilowatt output power. Both inverters have two MPP trackers and the extra battery input to connect a DC coupled high voltage storage. Yeah, now I want to explain you what is an LCA. Maybe some of you are familiar with this triple bottom line approach. That's basically the three dimensions of sustainability: people, planet, profit. So a product or a service has to cover all these dimensions. When it comes to people, society, of course, a product must not negatively affect the society, people. That's one big part. Of course, a company like Fronius, we have to be profitable. So to be sustainable, we need profit, of course. And today we are in the third dimension, in the planet dimension, with a life cycle assessment. That's basically a sustainability assessment of the environmental dimension. So how is our inverter in this case affecting the environment? Why is a life cycle assessment so important? We need evidence-based sustainability. I think today we are a lot of experts here, and we know that we need, when it comes to sustainability, we need facts, facts, facts. Sustainability is a very, let's call it, sensitive topic. Every company or manufacturer is nowadays sustainable by doing cardboard packaging or no plastic bags anymore. But sometimes that's greenwashing. So just claiming to be sustainable without really being sustainable. And for real evidence-based sustainability, it needs, as I said, facts. So high transparency is very important here. And that's what we can offer now with this comprehensive life cycle assessment. Also, the customer requirements are changing. I just put some statements here of our customers. They want system with the best carbon footprint. They want to know the usage of recycled materials from the inverter to get, for example, fundings from the EU. Yeah, they want to know how much CO2 the production of the inverter costs in their country and so on. So a lot of customer requirements. And for this, of course, the results of such a life cycle assessment are also very important. Another important point, upcoming CO2 pricing. I just put some measures here in Europe, for example, the European Green Deal, maybe you know it. I think the EU wants to be carbon neutral until 2050. And to reach these goals, LCAs will becoming crucial because we need a measure to evaluate this this pricing. So to find a price, we need scientific data for it. That's crucial in future. Yeah, now I talked about, let's call it the problem or the status quo, and now we're going to the solution. Before we go into detail about the product or our specific life cycle assessment, I want to give you an overview of a general life cycle of a product. So a life cycle is basically always the same or very similar. It's starting with the sourcing phase. So where does the raw materials come from? In our case, for example, aluminium. Where does the aluminium come from? Of course, this needs also CO2 or has a climate impact. Then there are the transport routes between the sourcing phase and the production phase. In the production phase as well, CO2 is getting embedded into the inverter because it needs, of course, energy to produce the device. Then again, transport routes to the customer. Now we are in the usage phase. So when the customer really starts to build up the PV system, and from there on, it's getting carbon neutral. So until the usage phase, of course, we emitted CO2, so that was a climate impact. And from the usage phase on, the inverter or the whole PV system is generating a climate benefit. Then, of course, we have repair processes. Of course, we want to repair the inverter as much as possible, as long as possible. But every product has an end of life. And that's also very important. The end of life has a huge impact on the whole life cycle of a product, because when we, for example, just compare a landfilling of the product with recycling, that's a huge difference. So of course, it would be very good to recycle the product, that it goes back in our production. For example, raw materials like aluminium or so. And to compare all these life cycle steps, there is one measure, that's the CO2 equivalent. That's just a comparable value to measure this carbon footprint of products. Yeah, now we want to look straight into our LCA of the Gen24 Plus hybrid inverter. I want to really emphasize that this is a project of the Fronius Research and Development Department. We really did this project in-house here in Austria, and that's what we're really proud of. Of course, we have some partners, for example, the Fraunhofer Institute in Germany. They also helped us and certified this methodology that we've done it correctly. This is the core team. You can see the project team that are just some people of the whole team. I think altogether we were like more than 50 people involved in this project, which lasted, I think, more than 1 year. So a huge project here at Fronius. Yeah, very important. There are a lot of different scenarios. So it's not that easy that you have one inverter in Austria and then you measure a carbon footprint. It's depending on very, very many criteria. For example, the location of usage. Is the system located in Austria, Germany, Australia, US, New York, and Los Angeles? We've modeled very different locations here because the impact of the different location is quite big. Of course, it's very important which modules you use. Do you use conventional modules? Nowadays, I think most of the people using conventional modules, but there are also more sustainable alternatives in the near future. We modeled those two different PV systems. Then we modeled 4 different power classes of inverter. Of course, it's extremely different if you're using a single phase inverter with 3 kilowatt AC output or a 3-phase inverter with 10 kilowatt AC output. So this has a huge impact as well on the climate impact. And as I said it before, the waste management scenarios. So we also modeled a lot of different scenarios here, from landfilling via thermal waste treatment up to recycling. So yeah, depending which waste management the customer is choosing, then this has also a very, very big impact on the carbon footprint, but more on this in detail later. Yeah, first of all, with a life cycle assessment in this project, you have to collect data. So I will give you just some impressions about the data collection. We have, of course, used a lot of primary data, which we collected in our R&D department and together with our suppliers of the raw materials. But we also used secondary data from, for example, databases like EcoInvent. When we talk, for example, about PV modules, we do not have this data in-house. We just found this data then in official databases. Just some impressions that you get an overview how this looks. There my colleague, we destroyed the fan of our inverter. That's a Pabst cooling fan that you just can see that it's very hard work, hands-on work, not only sitting in the office and writing protocols, it's also really hands-on. We also looked for gold at the inverter. We found some gold that's on the PC boards here, on the plug connection. There my colleague also destroyed or dismantled the inverter. Of course, when dismantling the products, all the safety regulations have been fulfilled, so no worries, nobody hurt here. There you can see we measured the coils and some technical plastics, the foil capacitors under the microscope. So you can see it's also a lot of hands-on work. The power consumption, very important at the production. How much energy is needed during the production and assembly of the inverter. There my colleague measured the power consumption. And of course, the end of life scenario, that's something we discussed with a big recycle company here in Austria. It's called Müller-Gutenbrunn. We did an excursion there, and we calculated with them together how the different waste treatments affect the climate balance of the product. For example, if you just burn the whole inverter or landfilling it compared to a recycling with the main parts. So that's, as I said, a huge difference. Yeah, then I want to select one scenario, one very practical scenario, because I can't tell you all the scenarios. We have more than 16,000 results here with this LCA, but I've picked a quite good one, I would say. That's a PV system with the SIMO Gen24 Plus 5 kilowatt inverter, so the 3-phase inverter with 20 years of operation in Germany. We're using conventional modules because it's nowadays normal modules which customers are using. And we're using a thermal waste treatment with subsequent metal recycling. That means that in the end of life process, the inverter is basically shredded into some small parts, and the metal is recycled, so the aluminium, for example, and the rest is treated thermally. Yeah, before I go into detail about the results, it's very important to understand the carbon footprint of PV systems in general. The PV system consists not only out of the inverter, it's also important that, for example, there are modules in the system. So the PV system without the inverter has already a CO2 backpack originating from the complex production. We calculated it with about 1,500 kilograms of CO2 equivalent per kilowatt peak system power, which is written off then over 30 years of lifetime. The service life of the inverter is calculated with 20 years. So from these values, we calculated the reference value around about 50 grams of CO2 equivalent per kilowatt hour AC output of the inverter to write off this CO2 backpack of the PV modules. There you can see the climate impact of the whole PV system. And what's very important is that the inverter accounts for 8% of the climate impact of the whole PV system, and therefore it receives 8% of the climate benefit. I think that's quite logic, but you can see here when we look at the whole PV system, for example, the PV cells, so the multi-wafer cells are having the most impact on the climate compared to the other parts. Yeah, that's a very important slide. That's the first slide with our results. There you can see on this chart, you can see the kilogram of CO2 equivalent, so the climate impact in kilogram CO2 equivalent divided into these life cycle steps. So let's start on the bottom. This is a negative value because we've chosen a waste treatment where we recycle the inverter or recycle at least the metallic resources, and therefore we get a credit. So we have a negative value here because we can basically substitute some new material, some new aluminium with this recycling method, and therefore we get a environmental benefit, so a credit. The components, as you can see, is the biggest part. I will go through all the steps in detail then. So 66.5% in our case with Germany would be the components from the climate impact. Transport to Fronius, production at Fronius, and transport to customer, as you can see, is very low. The impact is really nothing compared to, for example, the components. Why this is so low, I will tell you also on the slides later on. And a huge part as well are the electrical losses during usage. That's very complex to understand. As I said, the PV modules, they already have a CO2 backpack originating from the complex production. And of course, this CO2, let's call it, is burned because the inverter, of course, does not has 100% efficiency. We calculated with 97% efficiency. So basically, you can imagine 3% of the DC energy, which is produced throughout the PV modules, is lost throughout the inverter because, of course, we have not 100% efficiency, as I said. And as we burn this 3% of efficiency, that has also a negative impact on the climate because the CO2 backpack of the modules. So in this case, the climate impact of the inverter would be around 415 kilogram of CO2 equivalent. That's just the climate impact. So the climate benefits, I will explain later. Of course, the inverter is producing also green energy, but on this slide, we just look at the impact on the climate. So basically the negative side. The positive things will come in the end, no worries. So the first part, components. By weight, that's very important, components by weight. You can see in this chart the separation of all the components by weight. We measured or modeled 412 components. That's 2,500 pieces. And the biggest part in terms of weight is aluminium, the technical plastics, coils, galvanized steels, cardboard, for example. Yeah, it's quite logic that aluminium is, because we're using an aluminium heatsink, that this is the heaviest part in percent kilogram. But let's look at the next slide. Maybe keep this in mind. Others, in the category others, there are the integrated circuits, the ICs, which is a very small part. On this chart, you can't see them, but on the next chart, that's the climate impact of the components. Aluminium has quite the same impact, like in terms of weight. So in terms of climate and weight would be quite the same. Technical plastics, coils as well. But for example, capacitors and ICs, these are very, very small components which have a huge impact on the climate. So very small and lightweighting components. But with this slide, I want to say that really small things can have a huge climate impact. Yeah, we look at not kilogram, percent kilogram, we look in percent kilogram CO2 equivalent. So not in terms of weight, just in terms of climate impact, just to give you an impression. When we talk about components, I want to talk about aluminium, because as I said, we're using aluminium in the heatsink for the cooling, and we're using 100% recycled aluminium. When we would use 100% new product, then the climate impact would be more than 1/3 higher than our current situation with 100% recycled aluminium from open loop recycling. That's, for example, old alloy rims or so. And yeah, that's very, very important for the CO2 balance of the product. So that's a very big lever, the alu recycling share of the product. Very, very important, and we're very proud here that we can use 100% recycled aluminium here in the heatsink. Yeah, the next step, transport to Fronius. So the raw materials from the countries of origin of the components to Fronius, that's also very low. We're using just truck, ship, and train here, no air freight. So that's why this value is very, very low. Production at Fronius, only 2.1% as well. That's also very low. We're using a lot of renewable energy here. We have like PV systems on all our production sites here in Austria. And also the energy from the grid we are drawing is green energy. So all the electrical energy we get here or we draw from the grid is from renewable sources. That's why the climate impact of the production is quite low as well. The transport to customer, again, in this case, okay, Germany, to be honest, this is not very far from Austria. So the transport to customer is also very low in this case. But also when we would calculate it for Australia here, it would not that much more because of logistics and so on. So the climate impact, really the big, huge part where we have to work on are the components and, as I said, the electrical losses, so the efficiency of the inverter. As I said, because the modules have such a huge CO2 backpack, that's something the inverter have to work off. And when the inverter cannot really use 100% of the energy the modules are giving or producing, then of course this has a negative impact on the climate. But I would say 97% efficiency is quite high. Yeah, I will see what in future is coming. I think the efficiencies are still increasing in the next few years. Yeah, and as I said, the waste recycling, there we get a credit because we have a recycling waste treatment, and that means that we can substitute new aluminium, for example, and therefore we get a credit. That's the different variants of waste recycling we modeled. In this scenario, for example, for Germany, when we would have used landfilling or just a thermal waste treatment of the inverter, then this would have a climate impact, so a negative climate impact. From this recycling variant on, for example, this is, as I said, combination of metal recycling with thermal waste treatment, we generate a credit, an environmental benefit. So very important, that's also a very big lever to recycle products, not only to landfill it or to burn it. Of course, these products have to be recycled. The best recycling scenario would be if you disassemble the inverter into the 6 main parts and then recycle it. I just put it on this slide as well. So dismantling and recycling of the 6 heaviest components generates the highest benefit. And we also dismantled our inverter here in Austria in the R&D sometime. It takes you 5 minutes roundabout. And so we really want to force our customer to recycle the stuff and dismantle it, recycle it, that really the climate impacts are not that high. Also, repair is highly beneficial. Fronius inverter are well known because you can repair them. You don't have to go on site and replace the whole device. You can replace the power stack. As you can see here, it's the Aluminium unit here. You can replace the fan, the data communication unit. All these components can be replaced on site, and all these repair processes generate a very high environmental benefit compared to an early replacement of the entire device. So that's very important to repair an inverter and not to exchange it. And I think it's also nice for installers when there are inverters in the field out there that they just can bring some components and not have to replace the whole device. I think that's also comfortable. Yeah, and now I talked a lot of climate impact, but now I want to talk more about the benefits. In our life cycle assessment, I only talk about climate benefits now, but we also modeled some other, let's call it impact categories. For example, fossil resources. How does the inverter affect fossil resources? How does it affect metallic resources, human toxicity, dust, and so on? But I would say the climate is the most important influencing factor, of course. And I talked just about this orange bar here. So that's the impact, so the negative impacts on the environment. But you can see here over 20 years of lifetime, the inverter is producing so much green energy that the overall CO2 balance is, of course, positive, or in this way it's negative because it's negative values. But we create a huge environmental benefit. In concrete numbers, we call it CO2 payback time. So that's basically the time when the inverter is carbon neutral. For this example, in Germany with the 5 kilowatt device, this would be 2.3 years across all scenarios. The best case would be 0.8 years. I think that was Australia because they have higher irradiation. And the worst case would be 3.7 years. Okay, let's look at the whole PV system. So now we looked at the inverter, and now we will look at the inverter and the modules. I also put some values about the energy payback time because a lot of customers also ask about the energy payback time. This would be overall scenarios between 0.9 and 2.1 years of energy payback time. And again, the CO2 payback time of the system in Germany, including the PV modules, would be 2.85 years. And across all the scenarios, so Australia, Brazil, and so on, it would be between 1.2 and 5.5 years. So also very, very good values. So the worst case all over the world is 5.5 years of CO2 amortization time for the whole PV system. Yeah, just a summary of the results. Between 1,600 and nearly 17,000 kilograms of CO2 equivalent are saved with the Gen24 Plus. This would be around 7.5 outbound and return flights from Vienna to New York. So 15 flights from Vienna to New York, what our inverter is compensating. The benefit exceeds the impact by a factor of 5.3 to 26. So again, depending on the scenario where the inverter is and so on, that's a huge number as well, I would say. The CO2 payback time, I already mentioned it, is in the range of 0.8 to 3.7 years. And again, we have an official review and certification of the Fraunhofer Institute in Germany, which we're very proud of, that we have all done this methodology and so on correct. Some further information, of course, we also have a white paper on this topic where you can see all the details about this life cycle assessment. I just linked it here. I think you will all get the slides and then you can just download it. We also have a blog article series on our homepage who is interested in, and I just linked the certification of Fraunhofer as well, if you want to have some proof that it's done correctly. Yeah, then I'm quite finished. I'm done. I would say thank you for your attention, and I'm really looking forward to some interesting questions.
Hi, Leonhard. Thanks. Yeah, very happy. Great presentation. So just a few questions. So of that project, how much of that actually are you already implementing of these possibilities for all your products?
You mean for which products we already have done such an LCA?
Yeah. Mm-hmm.
At the moment, it's just for our new hybrid inverter, the Gen24 Plus. That's the only inverter where we have conducted this LCA so far because it's quite new and it also takes some time, to be honest. It was like, yeah, 1 year of developing phase for this project. But the Toro, this is our commercial inverter, would be the next product where we plan this life cycle assessment.
And in terms of recycling and in terms of return of materials, so how are you handling that? Are you doing that for all products, and how does it work?
That's something we do not really have in our hands, what the customer is doing then with the inverter. So we can try, or we still do try to use a lot of recycled materials in the production here at Fronius, in the first production of the product. And we, of course, have repair centers all over the world. So, for example, here in Austria and Australia. So we really focus on repairability of the inverter. Our customers really like this. They know that they can replace PC boards, power units, fans, and so on. And that's what we are forcing. And when the inverter is done sometime, then they have to send over the inverter to the repair center and they get a new one. So with our inverters, you do not have to replace the whole device, just in the worst case.
Mm-hmm. So there's, as you said, actually the 3 Ps are also profit. So if you talk about the additional costs and if you implement all these measures by using recycled material and really take care for all these sustainability aspects. So how much more does it cost? So what's the return on invest in this?
That's some numbers I would have to ask my sales colleagues, but as far as I know, for example, the aluminium share, what I know is that recycled aluminium does not need to be cost more than new aluminium. So I think recycled aluminium is cheaper indeed. And for example, aluminium is a raw material you can recycle more than 100 times. So there is, it doesn't get any worse. So this is, huge for us because we have a better profit, let's say it in the end, and we're using we have a better climate balance.
Okay.
But the exact ROE in regards of sustainable material, that's a number I can't really give you in detail, sorry.
Okay. And in terms of take back of the inverter at the moment, I think, are there any preparations by the industry? Are you seeing that products have to be returned at some point so that they will be recycled, or what are you seeing there?
I think that in near future this has to be done. I mean, we do it, we already do it, but I think this has to be done by the whole industry. When there are CO2 pricings and so on, then we cannot simply replace all the stuff. I mean, when an inverter is a very complex product, but let's look at mobile phones or so. I mean, maybe you and me, we change our mobile phone every 1 or 2 years, but that's not the way to go, in my opinion. We need to try to recycle a lot, try to renew the product or use refurbished products. So I think that's the way to go in the whole industry, not only PV industry, also module industry, or laptop and computer industry.
I did buy a used iPhone.
Perfect.
But okay, cool. I think that's it. If there are any other questions regarding sustainability, please get in touch with Leonhard. I think he will, you can put it in or write it down in the chat or send him an email, actually. If you also are interested in the topic of sustainability on a larger scale, now I advertise a little bit for Solar Power Europe. So we're dealing at the association a lot with that topic. There are also some legislative things taking place in Europe, which will have effects on modules and inverters. So that's eco labels, eco designs, and I think everyone should have that on his or her radar. So thanks again for this great insights and also showing this leadership in terms of sustainability. Thanks.